Trigonometric function video number 8. Let f of x, for example, equal y equal minus sine x minus cosine 2x. We need to to draw this function, right? Okay, let's start first to find a period to start with instead of drawing all of it, because it's my domain is from minus infinity to plus infinity of sine x and cosine 2x, right? So we just pick up some interval, and we can draw this interval, and we can continue the same thing over all intervals with periodic 2 pi, but we have to prove it. So instead of x, let's put x plus 2 pi minus cosine 2x means 2x plus 4 pi. We know that sine x and cosine x are periodic every 2k pi. This means it goes back to minus sine x minus cosine 2x. In this case, it's equal again to f of x, so it's periodic every 2k pi. That's great. So we can choose some interval. I'm going to choose from minus pi over 2 to 3 pi over 2. We can choose from 0 to 2 pi, whatever, right? But let me choose from negative to positive part. So this is 2 pi, right? From minus half pi to 1.5 pi. Since we have equality here, right? Equal to minus pi by 2, equal to 3 pi over 2. So we have endpoints. What are my endpoints equal to? F of minus pi over 2 is equal minus sine of minus pi over 2 minus cosine of 2 times minus pi over 2. It's minus pi, which is equal. Sine minus pi over 2 is minus 1 times minus. It's 1 minus cosine minus pi is also minus 1 times minus. It's plus 1, so it's equal to 2. And those are endpoints, right? F of 3 pi over 2, it's equal to minus sine 3 pi over 2 minus cosine of 3 pi. 2 times 3 pi over 2, it's 3 pi, equal sine 3 pi over 2. 3 pi over 2 is minus pi, by the way. 3 pi over 2, it's minus pi over 2. So it's also 1 minus 3 pi. Take out 2 pi, it's 1 pi. 1 pi is minus 1, so it's again 2. So those are the end points of my interval. We don't have end points anyway, but of this interval, these are the end points. Second, we try to take the points of intersection with the x-axis. So let's choose the x-intercept. When we have x-intercept is when y equals 0. Y equals 0 means minus sine x, right? Minus sine x minus cosine 2x is equal to 0. Cosine 2x, we know that cosine 2x, we can find it in terms of sine. It's 1 minus sine square x. It's a formula, trigonometric formula. This implies that, right, minus times minus sine square x, it's sine square x. No, sorry, it's 1 minus 2 sine square x, right? 1 minus 2 sine square x. It's 2 sine square x minus sine x minus 1 equal to 0, right? We can, sorry, for this video, I want to do it in one video only. So within 10 minutes, we should finish this one. So working a little bit fast. So 2 sine x times sine x plus 1 times minus 1. We can check it, and we can find this is true. So either 2 sine x equal plus 1 equal to 0. This implies that sine x equal negative half. This implies that sine x equal sine of minus pi over 6. This implies that because sine minus pi by 6 is minus half, right? It's either x equal minus pi over 6, which is plus 2k pi, which is including to my domain, or pi minus pi over 6, right? Pi minus alpha pi minus sine pi by 6. So x equal pi minus of minus pi by 6. So this implies that x equal 7 pi by 6, also including to my 7 pi over 6, also including to my domain or my intervals. The intervals we took. Or we have another one, sine x minus 1 is equal to 0. This implies sine x equal to 1. This implies that sine x equal sine pi over 2. Sine pi over 2 is 1, right? So either x equal pi over 2 or pi minus pi over 2, which is also pi over 2. So we have three cases of x-intercepts, right? We have three cases of x-intercepts. Now, we find y-intercept. Y-intercept is 1, x equal to 0. This implies that minus sine 0, right? Y equal minus sine 0 minus cosine 2 times 0, also 0, which is equal minus sine 0, 0 minus cosine 0, 1. So the answer is minus 1. So the x-intercept, the y-intercept is when x equals 0 and y equal minus 1. That's great. After that, we find directly the derivative. Derivative of minus sine x minus cosine x. Derivative of minus sine x is minus cosine x. And derivative of minus cosine to x is minus, again, sine to x times 2 sine to x, which is equal minus cosine x plus sine to x, it's 2 sine x cosine x times 2, it's 4 sine x cosine x. We can pick up as cosine x as common factor into 4 sine x minus 1. Taking y prime equal to 0 means this will be equal to 0. Then either cosine x equal to 0 means cosine x equal cosine pi over 2, right? Cosine pi over 2. This implies that either x equal pi over 2 or x equal minus pi over 2, right? Those are two values for cosine x equals 0. Or 4 sine x minus 1 equals 0. I'm sorry. 4 sine x minus 1 equal to 0. This implies that sine x equal 1 over 4. Here we need a calculator because I don't know what is x equals to, right? In this case, x should be equal, because it's not a particular point. Here on the calculator, sine inverse of 0.25, because 1 over 4 is equal to 0.25, approximately 0.25. So x is approximately 0.25 or pi minus 0.25. This means x equal pi 3.14 minus 0.25. For sure, we are working radians here. It's approximately 2.9 approximate values. So we have, how many values we have here? This value and this value, this value and this value, right? Okay, what do we have else? We go directly to table of variation and then we draw the graph, right? I took the interval from minus pi over 2 to 3 pi over 2. This is y prime, this is y, and we have 3 more points like 0.25, like pi over 2 or 1.57 and 2.9, right? If we know that this is 0, this is 0, right? Y prime at those points are at 0. Okay. Because what's the meaning of minus pi by 2? Plus 2k pi. I can add plus 2k pi over here. This means x is going to be 3 pi over 2. Right? So 0 here, 0 here, 0 here, 0 at 0.25, at pi over 2, which is 1.57 radians, and at 2.9. We can pick up point. This is minus 1.57, right? And this is 3 pi over 2. It means 3 times 1.57. 3 times 1.57, that's true. Which is whatever. We choose any point between minus 1.57 and 0.25, and we substitute it in y prime by calculator. We are going to see this is negative, positive, negative, positive. So my curve is going to be like something like decreasing, increasing, decreasing, then increasing. And the points, if you remember, were 2, right? And by calculator, I found those already. It's minus 9 over 8. This point is 0, and this point is minus 9 over 8 again, right? So if x is 0.25, substituted in y, we are going to get these answers. All right, that's it. And we draw. It's very simple. It's very simple. We can do it in and like that in a fast way, right? And by the way, this is my drawing, this is my graph on the table of variation exactly, right? So let's try to draw. Oof, let me use this. Okay. All right. Now we can, this is y-axis and this is x-axis. The main points I got, 0 minus 1, if you go back, you find this is x-intercept, right? 0 minus 1. This is, I'm sorry, y-intercept, right? Um, we have those points, minus pi over 2, which is minus 1.57. This is minus 1, this is minus 2, this is minus 1.57, right? The derivative here is 0, right? And simply the y is 2 minus 1.572. So y, the curve passes through this point. 0.25, it's a quarter for x, and minus 1 and minus 9 over 8, 1.125. This is quarter, this is 1.125, somewhere over here, right? We can 1.57, it's pi over 2, 1.57, 0, 2.9, this is 3, all right, minus 1 point again over here. 3 pi over 2 means 3 pi over 2, it's like 4 and a half, 4.7 something, right? 4.7 something, 2, 3, 4, 4.7 something, 2, somewhere over here, right? And that's it. That's it. We can draw the curve goes down from this point, right? Passing through this, from this point, passing through minus 1 to this point, go back up to this point, go back down to this point, it goes back up to this point, passing through the x-intercept. The x-intercept is 3 pi, how much? 7 pi over 6 somewhere, right? Somewhere, and go to here, right? And for sure, it continues in the same manner. All right?